let's deal with relations and functions. So a relation is just a set of ordered pairs. And a relation, what that means, a set of ordered pairs, is we're going to have some x value and some y value. Now, is a relation always a function? No. Is a function always a relation? Yes. Let's look at, first of all, when we're dealing with relations, the domain and the range. Now, if you remember from grade 10, the set of elements in x is called the domain, and the set of elements in y is called the range. Now, what does that mean? Well, that's just big math fancy terms to say that the values for x are called the domain, and the values for y are called the range. We use this word elements because we're going to look smarty and mathy in grade 11, so we're going to deal with these elements now, and they're just number values. Now, sometimes we're going to have a relation or a function where the domain and range is the element of all real numbers. Now, what we do in math is we use this little notation, this XER, and I've just done it for you right down here. What this means is that all the values for x are included, or sometimes written as all real numbers. In math, we get lazy and we want to create symbols so we don't have to write whole real numbers every time, so we can just write this XER. So if the domain is all real numbers, we can just say x is an element of the real numbers, and if the range is all real numbers, you just say y is an element of all real numbers. So that's just notation. So what about trying to figure out what the domain and range is, or trying to determine what the domain and range is? Well, the first way, and the easiest way, if you can, is to draw a graph, draw a picture. So if we can, given our relation, draw the graph, then we can determine the domain and range. So we can just look at the graph, and this example down here is what we're going to do. We can just look at this graph and determine what are the possible values for x and what are the possible values for y. So when we look at this in our graph, when we're trying to determine domain and range, what we're really looking for is maximum or minimum, those endpoints, those possible values that this could be. If we look here, this graph tells you, this arrow indicates that this graph is going to go on forever like this. And the other arrow over here tells you that it's going to go on forever like this. So as we can see, if we're looking for the domain and we're looking at the x-axis, in this case, every value of x is allowed. So the domain, in this case, we would just say is all real numbers, or that XER notation. So all the values for x are allowed in this function. What about the range? Well, the first thing we can check and see, is every y value allowed? Well, of course not, because if I picked y equals -1 down here, I'm not on the graph. So this is where we're trying to work with the minimum or the maximum value. So right down here at the vertex of this parabola, that is the minimum. This is the smallest value that your graph will show. So from there, we're going up, everywhere higher than that. And as it says here, domain and range can often be expressed with an inequality. So we're going to create an inequality that says the smallest value is 0, and we're going up from there. The range is y is greater than or equal to 0. Those are the y values that would be determined by the domain. So let's look at another example. Let's look at one where we have some minimums and maximums on both ends. If we look at the circle, we can see that if we're looking for the domain, that the x values start right here. This is the smallest x value that this circle can touch. And what's the largest x value? Over here. So now we want to include all of the x values that are between 6 and negative 2. So what we have to do is we have to write this inequality, or this relation, this domain, like so. So we're going to start with the smallest value. The smallest value is negative 2. Now negative 2 is our smallest value, so it's going to be less than or equal to x. And remember, it's x because we're dealing with the domain. And x is going to be less than or equal to 6. This is the notation that we use if we're trying to write the domain or the range where we have a starting point and an ending point, or in this case, a minimum and a maximum. And this notation, what we have to notice about this notation is that we're always going to be using less than or equal to in between. Now, it doesn't necessarily have to be equal to. The function or the relation determines whether it's equal to or not, but it's always going to be less than. So we're going to use all that math knowledge, and we're going to take this leap here, and we're going to say that if that's what the domain is, the range, if we look here, the smallest value in the range is a negative 6. The largest value in the range is 1. So in this case, the range is negative 6, which is less than or equal to y. It's less than or equal to 1. So there's our domain and range.